Hey everyone, so I'm sure you've all been very interested to hear about the Higgs boson and what it actually means in terms of particle physics. But I know a nagging question that's been bothering a lot of people is not just what it's all about, but how is this of any use to anyone? Particle physics in general doesn't really lead to the same kind of innovations you'd see for all sorts of things like medical advances or new forms of technology we can use in our daily lives. I mean, knowing the four forces that make up the universe and the 12 particles that are involved in that whole process, that doesn't really change how we live our lives. We seem to get along just fine not knowing about them. So sometimes people wonder, like, why do we even bother with these science experiments? Now, putting aside the obvious fact that knowledge for knowledge's sake seems entirely worthwhile, and I don't see why anyone would want to stand in anyone's way of understanding how this universe works, there is the valid question of the amount of money and resources that gets put into these science experiments. Now, recently I was reading an article from The Telegraph by Simon Johnson that was titled, "Higgs Boson, What's It For?" "I have no idea," says Prof. And overall, it was actually a pretty good article, but it could nonetheless go out of its way for describing that the Higgs boson doesn't really do anything, or at least we have no application for it that would be practical in any sense of the word. Now, first off, let me just clarify quickly. The quote of Professor Higgs saying he doesn't know what it might be for was taken a little bit out of context. The full quote is, now the fact that they had to go all the way back to 1964 to find this quote is a bit amusing. You'd think they would ask Professor Higgs something, I don't know, at the announcement that Higgs boson has been confirmed, but nonetheless, moving along, I'd like to read another quote. This one comes from Sir Ernest Rutherford. For those who don't know who he is, he was basically the father of nuclear physics. He discovered that atoms have a nucleus. Anyone who knows anything about basic physics knows that that's pretty huge. I mean, the nucleus, that's literally what holds atoms together, pretty much. And in 1933, he said this. Now, that quote coming from 1933, I'm sure you all know that Sir Rutherford was proven to be quite wrong within about 10 years or so when the nuclear bomb was developed. And then, of course, we had nuclear energy soon afterwards. And it just goes to show that just because someone discovers something doesn't necessarily mean they know all the applications for said thing. So even if Higgs doesn't see any use for the boson he discovered, or helped describe, I should say, then, well, that doesn't necessarily mean we won't be able to find an application for it in the future. Now, the second point I wanted to bring up, though, is that part of this search for scientific truth often involves creating a lot of new technologies just to discover it. Now, to use an example to illustrate that, when scientists needed to share a lot of data with one another, experimental data, over great distances and very quickly, it was soon discovered that you could network computers together, and soon the internet was born. And that's just an example of one type of technology that was partially developed in the search for scientific truth. Now, this internet was actually partially put together by CERN, or the, and this is in French, Conseil Européen pour la Recherche Nucléaire. That means the European Council for Nuclear Research. That was their name in 1952. They changed it in 1954 to the European Organization for Nuclear Research. They kept the name CERN, I guess because that sounds better than ORN or whatever it would have been. But, well, there's a little history for you. They were one of the organizations that helped put together the internet, and they were also one of the organizations that helped build the Large Hadron Collider, which was used to discover evidence of Higgs boson. Now, a particle accelerator seems a lot less useful than a, well, information network, which seems obviously useful, but Well, you can't entirely rule rule out the use for particle accelerators. Proton accelerators are actually used in medical treatments. So some of the technology designed to find traces of the Higgs boson could be used in the future. And it just takes some time to see if they can be applied. But the point is, we have them now. And I guess the final point I wanted to bring up on this is a little more philosophical. Let's say if we're just talking about the Higgs boson itself and what practical use it could have. Now, it's true in the last 50 years there haven't really been any discoveries in particle physics that would impact our everyday lives. So let's say, there's like a 1% chance the Higgs boson will do anything. That's not the best odds, but you know what? If we didn't discover traces of the Higgs boson to more or less prove its existence, then, well, if we had just said, forget it, we don't need science, just leave us alone, well, that's a 100% of it never helping us, or a 0% chance to get anything out of it ever. And if we're talking about what we can get out of science, even the smallest chance seems better than not bothering and having no chance at all. Now, I personally think the search for knowledge is always worthwhile, but I just wanted to put that in perspective for anyone wondering what the Higgs boson might mean for us in our daily lives, and hopefully I described that a little bit better for you. So, appreciate that we have the Higgs boson, or have discovered traces of the Higgs boson to be specific. And thank you for watching.